So now that we've talked a bit about how to design a memoizer, namely use a concurrent hash map and implement the function interface and use the compute if absent, atomic check then act semantics, blah, 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 let's talk about how to actually implement this class. And we're going to use the concurrent hash map, of course, to do it. So here is the skeleton of the memoizer class. You can see that class memoizer is a good old generic, so it has a key and value that's parameterized. You can see that it implements function, and that means that you can use a memoizer transparently whenever a function is expected. So if you have an interface that expects to take a function, you can pass a memoizer to it, and then that'll transparently optimize the lookups so that repeated keys don't have long-running computations associated to fill their values. You just look up the result and get it back after the first time it's called. Here is the concurrent map that's used. So we have a field called mcache, which is of type concurrent map, and you can see that that's set to a concurrent hash map. So we have a concurrent hash map, and that's the map that associates the keys with the value that's produced by the function. That obviously raises the question, what's the function? Well, the function is basically something that is used to compute the value for a key that is not yet in the map. So if the key has not been put in the map, it's the first time it's put in the map, then we're going to go ahead and compute the function. And you'll see that the constructor takes a function and a map, and it goes ahead and updates the fields. And notice something interesting. We're going to parameterize both concurrent hash map and function. So I guess I should really say both concurrent map and function, because it could be something other than a concurrent hash map. We could use some other kind of map implementation if we so desired. Okay, so here is the apply method. This is the one that's going to get called back to get the value for a given key. So that's just good old apply. That's what we get by implementing function. So you can see here that what we're going to do is we're going to call compute if absent, which is this atomic check then act method that comes in as part of concurrent hash map. And the neat thing about this, as I mentioned before, is even if multiple threads call compute if absent at the same time for a key that does not yet have a value, the function is only called one time. So compute if absent is this super clever implementation that will ensure only a single call to the function is made. And once that result comes back, then any other threads that are waiting to get the value back from that key at that moment will all magically start forward with the computed function result, which becomes the value. So it goes and looks up the key in the cache. If the key is not present, then and only then do we atomically compute its value, and that's the atomic check then act capability. And that's kind of what we might call lazy evaluation. You only do something when you need it. And the first time in thread, the thread that's the first one to call compute if absent, won't block because it's calling the function to do the thing. Now, the function may take a while to run, so I guess it might block in that respect. It won't block on any synchronizer. But any other threads that come in for the same key will block until the first thread in finishes calling the function, gets the value back, puts the value in the map, and then propagates that off to all the other waiting threads. Now, of course, there might be no other waiting threads at the moment, but if there were, they would all wait until the value is computed, and then they would proceed. And we'll talk later about how that actually works. There's some really clever ways that that works under the hood. So compute if absent will return the value which had either been existing already, if this was not the first time in, or if it was the first time in, we just computed it and updated the map. So it's a really cool semantic, and it's exactly what we need for our memoizing cache, right? Because we want to basically amortize the creation of the first time value and then reuse that over time. The remove method is going to take the key and remove it from the map. So it will remove the key and, of course, the value and take them out of the map. You'll see that there's some other remove methods that ConcurrentHashMap supports, but this is the one we're focusing on at this point. So that's basically it. Very simple, very cool memoizer. You can reuse it for all kinds of interesting things. We will see later in the course that there's other ways to improve this memoizer by using something called a timed memoizer. And time memoizer is going to have this cool property that if you put stuff in the cache and then don't access it for a while, it'll automatically purge entries that have become stale from the cache. And it uses some cool timers to do that.